This is Mr. Beck Does Your Homework. This is physics homework number 11, question number 8. Very similar to question number 7, but what's different here is that this force is pushing down and to the left. Down and to the left. So now you're going to have an x component to the left and friction to the right. You've only also got the one force, not the two. But since this is down, your y component is going to be down. Let's see how all that works. A 900 Newton crate is being pushed across a level floor by a force of 307 at an angle of 20 degrees above the horizontal. The coefficient of kinetic friction is 0.17. The acceleration of gravity is 9.81. What is the acceleration of the box? Very similar problem. Start, free body diagram. Down, I've got gravity. I've got this push force down and to the left. I will have a normal force up, and I will have friction to the right, because that's opposite the direction of motion, parallel to the surface. I don't know what friction is. In order to get friction, I need the normal force, and normal force won't equal gravity because of this monster. So let's split the monster. It's down and to the left. That is 307 newtons, so that's my F push. And the F push will be the result of an Fy in the down direction and an Fx to the left. So now if I redraw my free body diagram with these components, instead of this push force, what I have is normal up. I have gravity down. I also have this Fy down, because it's down and to the left. I have Fx to the left, and I've got my friction to the right. The acceleration is what we're looking for, the acceleration of the box. So I'm guessing that this is going to be more than this, causing a net force to the left. But up and down are going to be balanced, because I don't expect this block to sink into the table or bounce off the table. So the equation I get from these is that my normal force in this case is going to equal my gravity plus my y. They're both pointing in the same direction. So gravity plus y will give me normal. So that would give me my normal force is going to be my gravity, which is going to be mass times the acceleration of gravity. So that's 900 times 9.81 for me. My force in the y direction is going to be, if I know my push, then my y is going to be the sine, is going to relate to the sine. So that's going to be F push times the sine of the angle. For me, these numbers are that the normal force is going to be, oh, mg, look at that, it's already 900 newtons. So they already gave me my weight of the object. They gave me 900 newtons straight away, so I don't have to multiply that by 9.8. But my push is newtons, and that's okay. Newtons times sine theta, so for me that's 307 times the sine of 20. That will give me a normal force. Now, my normal force, gravity plus y. So now I know my normal force. Now I need to find out my frictional force this way. Well, I know that my force of friction is going to be mu times my normal force. So if I take this number, multiply it by my 0.17 mu, then I will get myself a force of friction. Now, force of friction to the right, force of x to the left. What's force of x? Well, it's the adjacent to this angle, so it's going to be push times cosine theta to get that adjacent. So I know that my net force here, I know it looks like I'm going backwards here. My net force is going to be to the left, Fx, to the right, force of friction. My Fx is going to be my F push times the cosine theta minus this force of friction that I got over here, right? So now, for me, this is going to be 307 cosine 20 minus my force of friction. That gives me my F net. Am I there yet? Not quite. It says, what is the acceleration of the box? So I know that my acceleration is going to be my F net divided by my mass. Oh, wait a second. 900 isn't my mass. That's my weight. So to get my mass, now I'm going to use my 9.8. So since my weight is my mass times gravity, my mass is going to be my weight divided by gravity. So it's going to be, for me, 900 divided by 9.81. And that will give me my mass of my box. So now that goes in here, my net force goes in here, and I will get myself an acceleration for this box. Slide that up so you see it's weight divided by gravity.